we're looking at the second part of trigonometry. I reckon we can actually break it up into 3 sections. The third one we'll probably just have a little bit of a look at. It's got more to do with the graphs of the trigonometry and how we get our solutions, more so actual solving. So with my year 11s, we sort of break it up into what we call numerical trig, which is all the rules. And then we have the periodic phenomena. So looking at the graph and how come we have more than one solution for things. So you just had your test, and I have to say there were some wonderful results for that. So I think Finn and Ash are the only ones here, so they might just keep their eyes closed in a moment. You can have your test back to have a look. But yes, that's the deal. When we have people absent, we just have to wait. So anyway, what we want to look at today is non-right angle trigonometry, and I will offer the mic to whoever wants to take over if you want to talk. Come on up. Yeah, Ollie wants to go for it. Come on. Oh, now he backs down. All right, so if you had a formula page for the non-right angle stuff, maybe you would like to go back to that, or if you're starting a freshie, there are going to be 3 rules, okay? And clearly, we've got a heading saying non-right angle trigonometry. Now, with right angle, it was all about the labeling. What were our labels? Opposite, adjacent, and hypotenuse. Now, we've got 3 labels with our non-right angle. Be ready for this because I'm not sure you'll be able to spell them correctly. The spelling is a little bit unique. Ready? I always get the spelling a little bit wrong, but anyway, let's try. Oh, what was it? Yeah.
Isn't that right angle though?
It's not right angle.
Yeah, there's a right angle at the top. Just imagine
They're mocking my diagram. All right. So non-right angle. Right angle only work for right angle triangles. The non-right angle will even work for the right angle ones. Okay, it works for every sort of one. And you might go, oh, why didn't you just tell us that? Well, sometimes you want to have a bit of difference. Anyway, so here we go. The capital A, that represents the angle, right? The length that's opposite. We watching, boys, at the back? The length that is opposite capital A, angle A, is called little a. The length that is opposite capital B is called little b. And the length that is opposite capital C is called, no, it's actually called P. No, I'm kidding, it's little c. Sorry. Oh. Looking at the sine rule first. And the sine rule is all about pairs. So by that, I mean an angle and its opposite side. So our sine rule, I know you're looking up there, but let's go. We're going to write it like this first, please. A over sine A equals B over sine B. And if you really wanted to, we could say equals C over sine C, but we're never going to need 3 pairs. We only need 2. Writing it down, Mr. McQueen. And you will also, I don't think, I'm setting it out now, I don't think you're ever even going to have to label A, B, C. Right? You're just looking for opposites. I never label a triangle A, B, C after the initial thingy. Now, we'll see it. The question was, how will we know? You'll see. Now, I'm sticking this here too, or sine A over A equals, a bit squishy, sine B over B. They are technically the same rule, they've just been turned upside down. Does anyone want to have a guess as to why we've got them turned up one way and up the other? Well, the question was, it looks better. So it looks better depending on the unknown that you have. So it's really nice when we have our unknown upstairs. So if our unknown is a length, then we're going to go with this rule. If our unknown is an angle, then we're going to go with this one. So the same deal, but it's just about ease of where your unknown is. So we're going to look at the sine rule today, and hopefully we'll get to look at the cosine rule halfway through, and that will then hopefully explain the GIFs. I love that. Does anyone know what Ross is doing there? Hang on.
Swearing, they do that.
Yeah, instead of giving his sister the finger, that was their code, so their parents wouldn't know that they were being rude to each other. Anyway. Oh, it's such a funny show. You never watched it. That's like a friend of mine, and he's never watched it. And it's like, oh my God, how are we friends? All right, so we've already seen this part. This was all the right angle stuff. My beautiful PowerPoint. Soka toa. All right, so here's our sine rule. This can be used for any triangle, whether it be right angle or not. We've got our lengths, right? We've talked about how it's opposite, and those are our rules here. So now we're going to... Yeah, but I discussed that. So Ollie's now going, didn't write equals C. I said, we will never need 3 lots of. Okay, so here we go. We ready? This is a typical problem. So I suggest that you might just do a quick little example, e.g. What we want to do, first thing we see that we are finding the length. Oops, I have to click in there. Right, we're finding the length, and you can see that we've got opposites. You don't have to draw the arrows, but I'm just showing you there that we have got opposite pairs. So you have to have one known pair, an angle and its opposite length. So we've got the 63 and we've got that 7. Does that make sense to everybody? If I was asking you to find this length, right, I don't actually have my angle. I mean, I could go 180, take those, but it has to be opposite the angle that you have. Does that make sense? So we write our, I mean, I don't normally label those. Don't label. So can you see that you wouldn't actually need to label this? It's just a length upstairs. So you'd go X over its opposite angle. I don't care if it's A or B, as long as they're pairs. Does that answer your question, Ollie? Where do I care if it's A, B, and C? No, I do not. So it's just about the pairs. So X over sine 76 equals 7 over sine 63. What is it that we want? X. So X is being divided by sine 76. How do we get rid of a divide by sine 76? Times. I know what it was written, right? So we end up with...
So we just leave the 7.
That's it. So you probably just need this blue here. Ooh. Well, that's big. You don't need the black there, and we know it's just a little algebra. Be very careful treading a fine line. Don't carry it on. And it's a calculator issue, and your job is now done. How easy. We've got one example. We're just going through to see if I want PR, right? So I want this length here. Do I have its opposite angle? No. But can I get it? Yes. And I don't even have to use trigonometry, right? So 180 degrees in a triangle. It's a little bit annoying to use PowerPoints and this. So yeah, we get the 43. So who can write down, or I'll be your scribe, what would be our rule for this one? What would you say? We want to find X, so we start with the X upstairs, and it's going to be over what? For those playing at home, I'm writing on the board, you just can't see it. Over sine 43 equals, now what's its opposite pair? Now, who said sine 15? It's not sine, because that's okay, accident. So it's going to be 15 over sine 82. I don't think you can get any easier than that, right? How do I get rid of the divide by sine 43? Times. That's it. No, that's it.
So it doesn't. Yeah, but so it doesn't matter. Like the letters don't even matter.
The letters do not matter. You're just looking for pairs. The reason that we have the letters is for us to write the rule so you know what the rule is and you can follow it, right? But after that, it's just pairs. I don't think I have ever labelled A, B, C, P, Q, whatever for using the sine rule, okay? I think while we're here, we're going to be very bold and we're going to go, I'm not going to bother, but just to show you, we were going to do this, we're going to use the book in a minute, but just to show you the bounce. I discovered the bounce. Yes, I went the theme. But anyway, so draw your diagram, label the sides. What about if we have the angle? So now we've got this, and we want to find angle ABC. So when we talk about ABC, it's A, B, C. So we're talking about this angle here, the one in the middle. Ollie, please look. You'll be asking me, but what does that mean, angle ABC? Because you're not looking. Do you know what?
Yeah.
We will do this one as an example. Let me just go through it and then I'll leave it up for you to copy. But please watch first, Osk. Please watch. So we want to find angle ABC. Now, I want to go back and replace. I don't like calling X an angle. What would I put normally? Theta. That's right. So if you want to put theta, you can. Now, wait. So you need to stop typing. People need to stop writing. I just want you to look, listen. I'll leave it all on the board and give you heaps of time. If I don't, you tell me. So, have we got pairs? Yes, we have, right? We've got X. We've got an opposite length there, but we've actually got, this is our beautiful pair here, 6 over 72, right? So, it's the same thing except we're not going to put 4 over sine X. We want our unknown upstairs, okay? So this time, what we're going to do is have sine X. I mean, I would again put it sine X over 4 equals sine 72 over 6. So here's your algebra. How do I get X by itself? You're first going to get sine X by itself. So how do I get rid of a divide by 4? Times by 4, and then how do I get rid of the sine? Sine to the minus 1, the inverse of, right? So you times by 4. Don't write that line because you would keep it all in your calculator. I'm just making you check that it was there. And then we go sine to the minus 1. Okay?
What does it say, sine x 0?
Degrees.
Oh, it wasn't listening.
Think about other stuff. Tom. Alrighty, here we go. You've got your heading, exercise 15C1. You've got today's date. We're rocking, we're rolling. Right, you're trying to form good habits. So we look at this, it's non-right angle, so we're not thinking SOHCAHTOA at all. We look and we go straight away, huzzah, we have a known pair happening there. Yeah? It's a known pair. I am finding a length or an angle. Length, which means straight away I'm going X over sine of its opposite angle. I'm being so slack, I'm not even writing A over sine A because I'm not even labeling anything. So it's X over sine of what is X's opposite angle? 32. Equals, what's on the other side? 15, excellent, over sine 46. Our job here is nearly done and dusted. I don't want X divided by sine 32, I just want X. So how do I get rid of the divide by sine 32 times, so fancy it up with you therefore, over sine 46, get rid of the divide, we times, and it's all about our calculator. Making sure your calculator's in degrees, type it in, let's get an answer. Okay? Shh, thank you. Just doing one, you're going to do one by yourself, and we're going to do the angle stuff. We are scooting along. So we've got pairs. The reason that I'm saying this is soon you're going to have mixed up questions where you might not have pairs. You have to recognize when do you use your sine rule, when you're going to use your cosine rule. So here we go. Got pairs, and I'm finding a length. So that means I'm going to start with it's x over what? Sine 55, right? Excellent. Sine 55.
Equals 6.3.
What happened to hands up? 6.3.
What happened to hands up, mate?
Exactly. Therefore, and this is just simple stuff now. We've done it a few times. To get rid of the divide by sign, we're going to times. And it's going to run a little bit like right angle trig. You'll practice the rules with basic triangles. Then they're going to chuck in worded questions for you. Okay? So we're getting practice, we're recognizing. So you do one more. You've got the page. Let's have a look. How about you do 2b? 2b and 3b. What do you reckon? So you 2b and 3b. And look alive, because we're going to do the next bit soon. Right, so I still want to look at the cosine rule, and I want to give you a chance to look at your test, so please don't make me pause and stop and start again. So here we go. We look at this. This is all under the exercise 15C2, where it tells you straight away, oh, you're using the sine rule to find the angle. So no massive surprises. But again, imagine this was just lobbed in an assignment or a test, and you had to find theta. The first thing you notice, it's not right angle. The second thing you ask yourself, do I have a known pair?
Yeah.
All right? So the fact that you have a known pair, that is telling you it's sine rule all the way. The next thing is you're finding an angle. So instead of saying 8.1 over sine theta, you say sine theta over, excellent, equals, and just remember sine and your angle. So if it's sine upstairs on the left, it's got to be sine upstairs on the right. And remember, I promised you, there is no labeling here. There's no labeling A, B, C, whatever. It's just hook up your pairs. Over 14.9. And now we do the same steps. Osk, you right? So to get rid of a divide by 8.1, you're going to times the other side. Can I understand that your silence there is that you get it but you're just stuffed?
No.
Or are you confused?
No.
We're okay? Good it? Okay, good. And then notice, well, you have to do this question, so I would suggest, yes, you write it down. How many of you use your answer key on your calculator? I'm a big fan of the answer key. So you are by all means entitled to write down exactly, type in exactly what you see here, and it would be fine. Sometimes I don't know what I'm doing. I'm working along and I'll just go sine 113 over, what was it? 14.9. Oh! 14.9 times 8.1. Right, got that. And then we go shift, sine, shift of the answer. Now, why you do that, Tom has a little bit of thing to do with the unit circle, but basically you can't shift sine or shift cos of anything that's more than 1 or less than -1. You'll get error, and I'll show you that in a minute. So there's our answer. Our angle is 30.02. If I tried to go shift sine of, let's say, 1.1, I'll get an error. Does not work. No, it doesn't happen. And if I tried to go, what happens if it's minus whatever? Again, I would get non-real. So it just gives me a little bit of a step to see, oh, have I got my working out right? And why am I getting an error? Is it because I've typed something in wrong or whatever? So it's a safety step for me, but if you just want to type in exactly what you see, that's fine. All right, nearly done. This bit that I have to talk about is really important. Same deal. So can you find theta, get your ratio, do exactly what we did in the purple over there? Do it. Go. Okay, thank you. So people who are getting calculator errors, I'll talk about that in a minute, but I've got like 2 minutes to do this, so please listen. So we've gone along, we've done this, we've gone, it's got our opposite, so theta over 128. We've got the pair of 31 over 71. It's beautiful, it's beautiful. To get rid of the divide by 128, we times. To get rid of the sine, we inverse sine. We get this answer. Now, if you're looking at two things. One, you look at the answers at the back. Billy, please pay attention, really important. You look at the answers at the back of the book, they don't get this answer. You look at the diagram. Does this look like an acute angle? No. So normally when we have a small angle like this, we can have sometimes we can have two solutions. It is what we call the ambiguous case. Ambiguous. Yes. It's what you call the ambiguous case. Why have we got the ambiguous case? Well, this is where I have to think. Oh, I think I've stuffed it. I picked this and I could see it, and now this information. So you've got an angle of 31, you've got a length of 128. And then you've got this length of 71. You can draw this in another way. And that's what this one would be. So think about, here's my lengths. This is 31 degrees. Do we agree? This is, I've stuffed it again. 128. But you could have this one, 128. This length did not have a set length, did it? So who's to say that this doesn't keep on going and that here, oops, here is your 71. So it can either flick in or it can flick out, like in the diagram. So you could have had the diagram that you've got is 31 and 128, right? But instead of this flicking in, it flicked out because this was a shorter length. But this would still be 31 degrees, this would still be 128 meters, and this would still be 71 meters. It's this length that can keep varying. Does that make sense? You can still have the same degree, you can still have the same length, and this will even be the same length. But this one flicks out, or it could flick in.
So it expects you to know that.
Right, it does expect you to know that. That's the ambiguous case. And watch out, it's really complicated to find out what the other angle is. I say that sarcastically. So this is what you have to do every time. Now, I already know for this one, I'm going to check for the pink, but I already know there's no ambiguous case because the angle is larger. It's when you've got an angle 35 or less, likely is there's going to be the ambiguous case. This is what we do to check. Are we ready? Because you are going to have to do this every time. So we check. We go 180, take the answer that we get, 68.2. What is 180 take 68.2? Those people who checked their answers at the back and said, I didn't get what they got. Oh, look at that. I've done 180, take 180. 111.8. Is that the answer that they got in the back of the book? Yeah. Yes. Yes, it is. So this could be our situation now. Does it always work? You have to check. You do this, 111. You go back up here. Is 111 plus 31, is that still less than 180 degrees? So that means you could have this solution or you could have this solution. You've got two. So if the question was find the angle and you didn't check for the ambiguous case and it existed, you would lose a mark if you only gave me one solution. Let's go back. Is there always going to be two solutions? Let's have a look at this one. So we said the angle was 30. So we check. What's 180? Take 30. 150. So could this angle be 150? What's 150 plus 113? It's more than 180. It's not possible. It doesn't exist. Right? So that's why we do a check. And it's not a big deal. It's a quick little 180, take away the answer you have, add it up there, check. So I'm going to ask you, can you try, I'm trying to limit your homework, guys, because I know it's thing, but at the same time, I wanted to get through more today. Can you try and finish all of question 1? So really that's only 4 questions. 4 questions, okay? That's for homework.